All right, so today we're diving into something that's a really big deal in the AI world. We're talking about how to get AI to think smarter, not just harder. And a brand new paper might have just cracked the code.
So let's start with a big question. When you give an AI a tough problem, you want it to think, right? You want it to deliberate. But how much thinking is the right amount of thinking? Is it even possible to know?
Because right now, large language models, well, they have a thinking problem. I mean, they're incredibly powerful. We all know that. But the way they reason can be super inefficient. Sometimes they get stuck, just spinning their wheels, generating tons of useless text. Other times they just don't think deep enough, and they rush to an answer that's just wrong.
And this really boils down to two extremes. On the one hand, you've got overthinking. This is where the AI just goes on, generating these massive, redundant chains of thought that waste a ton of energy and compute power. But on the other hand, you have underthinking, where it just jumps to a conclusion way too fast and makes a simple, avoidable mistake. It's a real Goldilocks problem, you know? You're looking for that just right amount.
So how do you find that just right? Well, this is where it gets exciting. Enter AutoThink. This is a really clever new approach from researcher Asankaya Sharma that's designed to solve this exact problem. The whole goal is to hit that sweet spot between being super accurate and super efficient.
AutoThink manages this with a really elegant two-step method. It's actually beautifully simple when you break it down. First, it figures out how much the AI should think by setting a sort of thinking budget. And second, it actively guides how the AI thinks, steering it down the most promising path to the right answer. Okay, let's talk about step one. The best way to think about this is like an expert dispatcher for the AI's brain. Before the AI even starts working on a problem, AutoThink uses this thing called a query complexity classifier. It takes one look at the question and says, okay, how hard is this really? And this is so important. But why?
Because not all problems are built the same. I mean, look at this. When researchers tested this on the GPQA Diamond benchmark, and these are seriously tough questions for PhD-level experts, you see a huge variation. Some are easy, most are kind of in the middle, and a good chunk are really, really hard. AutoThink's classifier figures this out beforehand, so it can give a big thinking budget to the hard stuff and a tiny one to the easy stuff. No more one-size-fits-all thinking. So once that budget is set, you get to step 2, guiding the AI. AutoThink does this with something the paper calls pivotal tokens, and you can literally think of these as cheat codes for reasoning. They're specific words or concepts that the system learns are really, really good at leading to the right answer.
So how on earth does it find these cheat codes? Well, the process is pretty genius. First, it just lets the model try to solve the same problem a bunch of different ways. Then, it looks at only the attempts that got the right answer, and it asks what words, what tokens kept showing up in the successful paths. Those are your pivotal tokens. Finally, it creates these things called control vectors, which basically act like a magnet, gently pulling the AI's thinking process toward these helpful words. It's like giving it a nudge in the right direction.
Okay, so a smart budget and reasoning cheat codes. It all sounds amazing in theory, right? But the real question is, does this thing actually work in practice? Well, the data really tells the story here. And the answer is a huge yes. On that super difficult GPQA Diamond benchmark, a standard or vanilla LLM gets about 22% of the answers right. Not bad. But with AutoThink, that number jumps to over 31%. That is a massive leap forward. In fact, that's a 43% improvement in accuracy. So let's be clear, this isn't just about being more efficient. AutoThink is getting significantly more answers right. But what about the efficiency part? This is where it gets kind of mind-blowing. The standard model, it used on average almost 8,000 tokens. That's a good way to measure computational effort to get to an answer. AutoThink, it did the same job in just over 3,500. That is a staggering 55% reduction in the amount of work the AI has to do. So it's thinking less, but it's getting better results. I mean, that is the literal definition of thinking smarter, not harder. And this isn't some one-off fluke. You look at another really hard benchmark, MMLU Pro, and you see the exact same story playing out. Better accuracy with way, way fewer tokens.
It consistently beats the baseline. So the big takeaway here is just crystal clear. AutoThink pulls off what a lot of people thought was a direct trade-off. It gets you higher accuracy with way less computational work. It breaks the rule that said you had to choose one or the other. And this line from the paper's discussion really captures the new way of thinking here. The big lesson is that how you strategically allocate your thinking power is actually more important than just the total amount of power you throw at a problem. And why does this matter to you, to us, to everyone? Well, for one, it completely challenges this idea that smarter AI just means we need bigger and bigger computers. It means powerful AI reasoning could actually run on smaller devices, maybe even your phone someday. And that paves the way for AI applications that are way faster, cheaper, and, frankly, greener. All of this leaves us with a really fascinating question to chew on. By teaching an AI how to manage its own mental resources this well, we're not just making it faster, we're arguably making it fundamentally smarter. So, if AI can learn to think this efficiently, what's next? What other complex human abilities is it on the verge of figuring out?